work through it. For this transformers problem, one person was asking about the terms, and so let's make sure that we're clear on this. This is the E generator. We're calling it generator because in the class we kept calling it source, or S, like ES, the E of the source. But we have another term of ES now, which is the secondary side, right? And you could say ESEC, like E secondary, but ES, and this is E primary, which is the voltage across this coil of wire right here. So that's why we call it EG, in case you're wondering why is it EG. Now, in this circuit, E primary is equal to the E of the generator because there is no drop anywhere else in the circuit. All of this voltage goes out into this voltage and then it comes back. So if you had a resistor up here or down here, you would have to calculate for what is the actual E primary. But since there's nothing else in this circuit, E primary equals the E generator. And it's actually the same for the E secondary equals the V load. Right? There's no other resistor or any other elements inside the circuit besides the load. So all of the current, or sorry, all the voltage that is induced across this coil goes into the load. So if I'm writing down just the equations that are on the formula sheet, and I see I load, I know I'm going to need at least these I's. Now, because like we just said, I secondary is I load, and I primary is I of the generator. And that one's pretty much always true as long as they're in series. You know, unlike the voltages, these I's are almost always going to be the same. So if I rearrange and I wanted to solve for I load, I have A times the current of the generator. The turns ratio is 4. That's what this says right here. This means that A equals 4. And then the IG is 25 milliamps. Note that I just took the magnitudes, and that's because I said that's really what these are, is we're solving for the magnitudes. And the way that we get the final angle is by looking at the dots. My dots match, therefore theta I is the same. The theta of I of one side, the phase of one, is the same as the phase of the other. So I have 100 milliamps, angle 30 degrees. There's I load. For Z load, we just take our favorite law, Ohm's law, and rearrange for Z of the load. V of the load was 60 volts, angle 0. The I of the load was 100 milliamps, angle 30. And what we get is 600 ohms, angle negative 30. Now, this is in polar form, but if I just go from polar to rectangular, I get 519.6 minus J 300. And those are in ohms. And that makes sense that I would have a negative J because I have a capacitor up here, right? And so this is the R if I'm looking at this load, and this XC is the 300 right there. So I can split those up, and now whenever I'm solving for the powers, I can use P equals I squared R. You wouldn't want to use V squared over R because the V that I have isn't the V across just the resistor. I have the V across everything. So, but the I going through the resistor is the same as the I load. So in this case, it's the magnitude, right, of I. I can take 100 milliamps squared, 519.6 because I'm just taking the R component, and I get 5.2 watts. I can do the same thing with Q, I squared X, just the magnitude, 100 milliamps squared, and the X is 300, and I get 3 VAR, and you need to either label it capacitive, or you could write Q equals negative 3 VAR, and that negative would tell me that it's capacitive. The last step is for EG, and for me, I'm going to write down exactly what I see on my formula sheet. I've done that all semester, still recommend it. Write down what it is and then turn it into the variables that we know. So the E primary in this case is the E of the generator, since there's no other elements in the line. And this E secondary is the E of the load, or you could say the V of the load, right? That is everything because there are no other elements. So I'll rearrange it now for EG. Once again, these are just magnitudes. EG is equal to A VLD 4 times 60, and that comes out to 240. That's the magnitude, and the angle, once again, the dots match. Therefore, theta V is the same. So it's still 0 volts.